I want to add a note just about how you can see different chromium oxidizing agents, because they're all kind of doing a similar thing to molecules, but they look different as reagents, so I wouldn't want you to get confused by those, because you might see them drawn in differently on different standardized tests. So we were using chromic acid, and I gave you H2Cr2O7. Now if I were to draw that out, that would look a little bit like this. These chromiums have d orbitals, so they can have more than 8 electrons on them. So that is H2Cr2O7. But you can imagine this is actually a dimer. It's two chromic acids put together. This happens when you have the molecule in water. Imagine separating that into two pieces. You could end up getting those in water. Because after all, you could imagine the hydrogen on one of these and the OH on the other, those could leave as H2O, and then you're just left with the molecule on top. So in water, these two molecules, they dimerize, and they form H2Cr2O7. Now, each of these molecules is H2Cr04. So that's really the same. These both exist in equilibrium in water. So if you ever see H2Cr2O7, that's really the same thing as H2Cr04. They'll do the same thing to a molecule. They'll turn, for example, the benzylic position into a carboxylic acid. So you could see either of them on a standardized test, so I wanted you to see both of those ways, and you could even see it in a third way. You could make H2Cr04 from chromium trioxide. That's CrO3. If you bubble that through water, you could see how that could turn into H2Cr04. So these are three different ways that you can see chromium oxidizing agents. All of these will always do the same thing. They're going to oxidize stuff. They'll oxidize the benzylic position to a carboxylic acid. They would oxidize a primary alcohol to a carboxylic acid. So I wanted you to see how chromic acid can really be drawn in three different ways, just in case you see one of